In the summer of 1969, NASA was operating under the pressure of rigid, politically set deadlines and the height of the Cold War. This pressure began in 1957 when the Soviet Union successfully launched Sputnik. It was the first artificial satellite in orbit, and it proved to the world that America was trailing in the race for technological dominance. The lead only grew in 1961 when Soviet cosmonaut Yuri Gagarin became the first human to reach space. For the United States, this was a second major psychological and strategic blow. President John F. Kennedy responded with a public mandate to land a man on the moon and return him safely to Earth before 1970. At the time, the technology to achieve this did not yet exist. Meeting that 10-year target required the coordination of 400,000 workers and a total budget of $24 billion, a scale of mobilization that redirected a significant portion of the American economy toward a single goal. Because the schedule was so compressed, the Apollo 11 crew was effectively testing experimental technology in a live environment, where any single mechanical failure would result in the total loss of the mission. On July 19, 1969, after 4 days of travel and 400,000 kilometers, the Apollo 11 spacecraft successfully entered lunar orbit. Once in position, the ship detached into two separate components. The command and service module remained in orbit, while the lunar module prepared for the landing attempt. Neil Armstrong and Buzz Aldrin boarded the lunar module, the Eagle, to begin the final journey down to the surface. While his crewmates descended, Michael Collins remained behind in the command module. He was tasked with maintaining the primary ship and its systems entirely on his own. Collins was the only link back to Earth. If he could not maintain the exact orbital path above them, Armstrong and Aldrin would have no physical way to reconnect and begin their return flight. Warning codes began flashing at mission control the moment the descent began. The mission was immediately threatened by a series of technical errors. The 1201 and 1202 alarms indicated the Eagle's guidance computer was controlled landing. Outside the window, Armstrong saw that the struggling autopilot was steering them into a field of massive boulders. He immediately switched to manual control, hovering above the surface to search for a safe clearing. As he searched, the fuel levels dropped to a critical state. Houston initiated a countdown to an abort, which would have forced the astronauts to ditch the descent and return to orbit without landing. The Eagle finally touched down in the dust with only 5% of its fuel remaining, leaving the crew with roughly 30 seconds of hover time before they would have been forced to abort. After Armstrong and Aldrin spent 2 hours collecting geological samples and deploying scientific instruments, they returned to the cabin to prepare for liftoff. Once inside, they discovered a fatal problem. An astronaut accidentally bumped the control panel, snapping off the plastic switch required to arm the ascent engine. Without it, the engine circuit cannot close. Buzz Aldrin improvised, jamming a ballpoint pen into the gap to trigger ignition. The entire return flight, backed by billions of dollars in aerospace research, ultimately relied on a plastic pen to bridge a broken connection. The technical failures and the improvised nature of the survival story led to theories that the landing was a fabricated production filmed on Earth. Skeptics frequently cite the American flag, which appears to move despite the moon's lack of an atmosphere or wind. The flag was designed with a horizontal aluminum rod along the top to keep it extended in the vacuum. When the astronauts planted the pole, the metal rod vibrated like a spring, creating the rippling motion seen in the footage. The absence of stars in the background is also a result of photographic exposure limits. During the lunar day, the sunlit surface and the white spacesuits are so reflective that a camera must use a fast shutter speed, which makes faint starlight invisible. The intersecting shadows that some suggest indicate studio lighting are caused by the lunar dust itself. Because the surface is highly reflective, it acts as a secondary light source, scattering the sun's rays and filling in shadows from different angles. The optical characteristics of the Apollo footage reflect the specific physics of a vacuum and the light scattering properties of the lunar environment. Despite the mission's success, the Apollo program faced significant public backlash. Economic strain and domestic unrest eventually led the government to end the moon missions by 1972. However, the program left a permanent economic legacy. NASA's demand for lightweight, perfectly reliable electronics forced the rapid development of integrated circuits. This massive government investment caused the price of microchips to drop by 90% in just 5 years, accelerating the computing revolution that defines the modern world. Today, NASA is preparing to return to the lunar surface with the Artemis program, aiming to establish a permanent presence for future exploration. Apollo 11 was a high-stakes gamble that demonstrated how intense pressure can accelerate the timeline of human technological development.